So let's go over this. Remember, is this your 8th grade module 1 warm up? This is part E. So if we were evaluating each expression, that means they want us to put it in standard form. They're telling us what to do, what we're multiplying by. We multiply by 1,000. There's 1, 2, 3 zeros. So we're moving this to the right 1, 2, 3 times. 5, 2, 3, 0. Okay. There's 2 zeros here, so we're moving it to the right 1, 2 times. So this should be 140. This is becoming, this is like 10 to the negative what? 1, 2, 3. So if we move this left, 1, 2, 3, we have 0.00284. Essentially, do you see how this gets multiplied by the 1? So everything follows in after that. Same thing here. We would have 0.0 and then 933. So you guys got? A typical dust mite is barely visible to the naked eye because it's very small. Because of its very small size. The average length of a dust mite is 10 to the negative second inch. Express the average length as a decimal. So this is 1 over 10 squared. Remember our negative exponent rule tells us that. What is 10 squared? 10 times 10 is 100. How would I write 100th as a decimal? This is the 10th place, so this is the 100th place. We should be able to switch very quickly to that. All right, hopping into our new packet. If you weren't here at all last week, you may have missed that packet. It's the one closest to the window if you do not have this packet. So last week we went over inverse operations. We talked about one-step equations as far as addition and subtraction go. So let's start on page 4, being sure we are showing our work properly. So you may have had a little bit of time. Was it Friday? Yeah. Question. Why don't you have it with you? Guys, it's math class. Bring your math thing with you, please. All right. What's the inverse of addition? Subtraction. So what do I have to subtract from both sides of my equal sign? 9. Minus 9 minus 9. So I have x. What's 9 minus 9? 0. So it goes bye-bye. What's 14 minus 9? 5. There's my answer. What's being done to m? We're subtracting 14. So how do I undo subtracting 14? I add 14. Make sure you do it to both sides of your equal sign. What's negative 3 plus 14? 11. Bring down my equal sign. Bring down my m. What is 14 minus 14? 0. So I don't have anything left. You see how we end up with just what m equals? Yeah. What's being done to p? Well, we have to make this a 0, right? How do I make negative 6 a 0? Add 6. If I add 6 to both sides, I have 0 here. I bring down my p. What's negative 22 plus 6? Excellent. Negative 16. Good. So in your head, you're thinking 22 minus 6, but my bigger number was negative, so my answer is going to be negative. So now what's being done to C? Feel better? What's being done to C? You're subtracting 17. So how do I undo subtracting 17? Add it. Make sure you are showing your work neatly so it can be followed. So C plus nothing is just C. Negative 17 plus 17 is 0. So that goes away, which was what we wanted to happen. What's negative 1 plus 17? You got it. What's being done to K? We're subtracting 8. So now we need to add 8 to both sides. Oh, what's going to happen here? K equals what? 0. Very good. How do I get rid of this 23? Subtract it. Make sure you do it from both sides of the equal sign. 4 minus 23. Negative 19. Be careful there. Bring down your equal sign. 23 minus 23 is 0. We did that right. So that we just got what was W left. How'd I get one? 4 minus 23. Right? Which is what we have to do, but we have to then know that negative 23 is bigger than 4 as far as its absolute value goes. So how do I get rid of the negative 25 plus 25? We have y plus nothing is just y. Now we're thinking in our heads 41 minus 25, which is 16, but our bigger number is negative, so our answer is negative. What do I have to do to get rid of that 27? Subtract it from both sides. Now our signs are the same, so we're finding the sum, so I can add these up. 13, so 43, but it's negative 43 equals n. And then finally, how do I get rid of that negative 18? All right, I just want to use this as an example. So sometimes I might be going too fast and I might think, oh, I'm going to add 5 to both sides. So if I added 5 to both sides, you see that then you'd have negative 13 plus a equals 0. So I haven't solved for a yet. It's okay if you add or subtract the wrong thing, as long as you do it to both sides, and then you see, oh, I'm not quite done yet, right? I have to get a by itself. So then I would add 13 to both sides, so that I would have a equals 13. I know, that would be the wonky way, right? Because wouldn't you add 18 to both sides? But sometimes you might add or subtract the wrong thing, especially if it's on a weird side. I'm just showing you that it's important for you to think through it. Does that actually equal 0? Or in this case, does it equal negative 13 because we did the wrong numbers? I wouldn't do this like this unless I made the mistake, right? But you can still get to the correct answer eventually. It just takes another step. I just want you to really think through, okay, does 27 minus 27 really equal 0? Does negative 25 plus 25 really equal 0? Just to double check your work that you're doing the correct step. All right, so that's review of adding and subtracting one-step equations. Now we're going to look at multiplication and division of one-step equations. So we have to recall that multiplication and division are inverse operations. To solve one-step equations involving multiplication, follow the same steps you use to solve equations involving addition and subtraction. So we have to locate the variable, right? Where is my unknown? What's being done to it? Use the inverse on both sides of the equal sign. And then we haven't been checking our solution, but if I put in 16 for x here, we would say 16 plus 14 does equal 30. 30 equals 30. That would check our answer, okay? So when we have a letter next to a number, what does that mean? A letter next to a number denotes what's being done. That means there's 3 x's, so multiplication. It denotes multiplication. The x is being multiplied by what? I just wrote multiplied because that's what I said. What is the x being multiplied by here? It's being multiplied by 3. So how do we undo being multiplied by 3? Divide it by 3. Excellent. So I'm gonna show division with a fraction bar. You're big kids now. We're gonna divide both sides by 3. I show that with a fraction bar. Do you see that? Now, 3 divided by 3 equals what? 1. So 1x I would write just as x. We want there to just be 1x, right? And we know what x equals, Kylie, right? So what is 36 divided by 3? 12. So then I could put it in 3 times 12. Yes, that equals 36. All right, what's being done to this m? When I have a number next to a letter, it denotes what? Multiplication. So m is being multiplied by what? 9. How do I undo being multiplied by 9? Divide by 9. So I'm showing this with a fraction bar. 9 divided by 9 over here is what? 1. Isn't that what we want? 1m. What's negative 108 divided by 9? Negative 12. What's being done to the n in number 3? Multiplication. N is being multiplied by negative 10. So I have to divide both sides by negative 10. Careful of your signs. Negative 10 divided by negative 10 is simply 1. So 1n equals 5. Very good. When our signs are the same with multiplication and division, our answer is positive. When they're different, it is negative. Lots of review there. What's being done to this x? Multiplied by negative 17. So I have to divide by negative 17. This becomes 1, which is what we wanted. 1x equals negative 2. Very good. So if you were putting it back in, you would say 17 times negative 2. I'm sorry, negative 17 times negative 2. I was like, wait, does equal a positive 34. Okay, any questions about multiplication problems? We undo multiplication with division. So what do you think these next ones will be eventually? Division. So how do we undo division? With multiplication. All right, so I'm going to put a parenthesis around both sides because parentheses denote multiplication. So if x is being divided by 17, I have to multiply by 17. And I have to do that to both sides of my equal sign. Remember, 17x divided by 17 is just going to be 1. So 1x equals whatever 17 times 3 is. 51? 51? Thank you for checking me. All right. Now I have to undo dividing by negative 2. How do I undo dividing by negative 2? Multiply by negative 2. If I were to write this out, this would be negative 2v over negative 2 equals 16 times negative 2, right? Instead, I just know that this is getting canceled out, so v equals negative. Excellent. And I could check that. Negative 32 divided by negative 2 does equal 16. What's being done to y in number 7? It's being divided by negative 8. So I have to multiply both sides by negative 8. So negative 8 times negative 2 is going to be positive 16. Very good. And this cancels out to be 1y. That's what we wanted. And again, you could check your work. 16 divided by negative 8 does equal negative 2. What's being done to this k? It's being divided by -11, so I'm going to multiply both sides of the equal sign by -11. It cancels out, k equals, add a 0 to it when we multiply by 10, right? All right, these next few, they mixed up, so we really have to pay attention. So P is being divided by 6. How do we undo division by 6? We multiply by 6. 6 times -4 equals 1P, which is we write as P. What's being done to the X in number 10? It's being multiplied by 6. How do we undo it? Divide by 6. So that becomes 1x, which is what we wanted. -30 divided by 6. Ooh, this one's tricky. What is being done to P? What's it being multiplied by? What's my coefficient? -1. Very good. So I'm going to divide both sides by -1. Dividing both sides by -1 is really just taking the opposite of everything, right? Would it make sense that the opposite of P is equal to -16? Yes. All right, what's being done to P for number 12? It's being divided by 4. How do I undo division by 4? Multiply by 4. If it's easier for you to not write over the numbers like I have been in rewriting the problem, do so. I always just think that's one less step that I will screw something up on, right? I might rewrite the problem incorrectly. What did I do? What's 4 times 36? 144. Very good. Questions so far? All right, so you should be able to complete the rest of page 4. You're gonna solve these. Remember, we undo multiplication by dividing. Whatever you do to the left side of the equation, you have to do to the right side of the equation. And we undo division by multiplying. So whatever you do to the left side of the equation, you have to do to the right side of the equation. Finish those two up and then finish that page up. Might even have a bit of time to get into Alex if you're fast.